Let's record. Hello, everybody. Thank you so much for being here. My name is Danica Resurrection. I'm with 3C Rent in the county of San Luis Obispo, and today we have a very exciting course on energy recovery ventilators, installation, energy savings, and compliance. And we have our experts here, Nick Brown from Build Smart Group and Scott Kelly from SK Fresh Air in our webinar today. And so before I pass things off to them, I just have a few logistical slides to go over. Um, Please make sure you are on mute throughout the duration of the training, and we do highly encourage questions, and we'll keep track of the chat. So feel free to put your questions in the chat, or you can also raise your hand, and we can go ahead and unmute you once the timing aligns. And this session is being recorded, and it will be shared with you along with the slides in the next few days. And I'll also share that in the chat later so that those who are just trickling in can have that information as well. And next slide, please. And so just a little bit about who we are for those who are new to the Tri-County Regional Energy Network. We are also known as 3C-REN, and we're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. 3C-REN is funded by ratepayer dollars collected through the public goods charge found on our utility bills. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we're able to bring those dollars back into our region. And next slide, please. We currently offer 6 programs focused around 3 services. We have our incentives, we also offer trainings, and we have technical assistance. And this training today is part of the Energy Code Connect program. And if you'd like to learn more about our other trainings or our other programs, feel free to visit our website. And with that, I'll pass things off to Nick and Scott Kelly to get us started. Thank you, everybody.
Thanks, Danica.
Yeah,
Hi,
thank you.
Scott. How are you?
Hi. All's well. How are you doing?
All right, good.
Good. So we'll get started on this.
Yeah, I'm really excited to share this with everyone. We hatched the idea for this class a year ago at the Quebec conference, I think, Scott. Um, but Scott and I met 15, 20 years ago when we were first starting out in energy efficiency and building science. We actually share a family tree of building science. I took my first class in 2007 at Long Beach State, taught by John Shipman and Wes Harding, in case any of you have ever crossed paths with those guys. And they were awesome and really kind of launched me into my career. And Scott, you had a similar early beginning?
I did. I went through the Clean Energy Workforce Training Program that actually disseminated, I think it was $90 billion of stimulus funds throughout all of the community colleges and for to help us become performance contractors and learn green building, etc. And of course, that 90 billion went into all types of things, solar and all
Hmm.
renewables, etc. But part of it went into the Clean Energy Workforce Training Program, and that course, those courses, I took with the 2 gentlemen he just mentioned at Long Beach City College. He was at State, I was at City. I did it a few years, maybe 2 years later than he did, maybe in '08 or '09. And so yeah, we share the same family tree, and it was so interesting to be educated way back then that our energy codes in California would be changing and advancing, and every 3 years things would be different. And where were they going, and how are we getting there? And for me, many times I would look to Nick, and Nick would tell me, okay, well, in 2025, multifamily is going to have ERVs in all the homes and blower door tests and things like that. So that's what has been very interesting is that the language was taught to us many years ago, and then we went
Right.
off in our own ways. Like I have my test kitchen in my construction company, and I think same thing for Nick all along as we go. And so here we are, and I think we've
Here we
got
are.
some good information for you.
And we've seen many of those things that started as best practices 15, 20 years ago make their way into the code. Things like solar, high performance walls and attics. Um, so it's amazing how far things have advanced. A quick introduction on me. I'm out of Long Beach, a little south of the 3C Ren region. This is my house and ADU that are both now all electric and net zero energy. They form a living lab, and I monitor the energy use of all the circuits in the house. And one of the biggest things I did for health was install an energy recovery ventilator. And I'll tell you all about how that came to be and why. But I have it operating. There's a supply duct behind me right there in the ceiling, bringing about 30 CFM of fresh filtered air into my home office, which I think makes me perform a little better. That's the concept. And I think so. We're going to talk about the energy savings. We're going to talk about how ERVs can help you comply with Title 24. We're going to talk about all these different advantages today, any one of which might be reason for you to decide to start incorporating them into your projects. But hopefully my journey and Scott's help you make an informed decision. I'm an energy consultant. I do Title 24 compliance for a living, and I teach classes for the Energy Code ACE statewide compliance improvement team on topics like solar and battery. I teach the class for architects. I taught one this morning at the City of Long Beach to all the inspectors on ADUs. So that's me. Scott, how about you?
Well, I am what is called a performance contractor. I do hold a general contractor's license, but I really think of myself as a specialty subcontractor. And the categories that we do are weatherization, insulation, and ventilation. So in my training, I was a high performance wall assembly guy, or what's called an envelope expert, right? So the envelope of the home. And then when I really went out as a general contractor and started to try to get HVAC contractors to install the ventilation part, none of them do it. None of them know it. No one understands it. And so I got into a position where I was like, I cannot tighten up these houses and build these super tight and not have a ventilation strategy when I've been trained that that's what has to be done. And
Yeah.
so that's really kind of my approach to performance contracting and constructing in the current time at this point in time. Basically, especially subcontracting company that I operate. It's my name, Scott Kelly Construction Company. And if you want, you can go to YouTube and type that in, and you'll find a bunch of videos on weatherization, insulation, and ventilation. But basically, today we're going to focus on the ventilation part. And I also have another company. It's called SK Fresh Air, which is ventilationkits.com. And basically, what we're doing is we're taking the we're helping the ERV industry duct their systems, if you will. So we're going to talk all about the ERV themselves, the machine that's right here. I call it, like, we call it fresh air machine, if you want. And basically what this thing is it's a balanced ventilation system, and we're going to go through all those details today. And so in my test kitchen as a general contractor, I was able to kind of work through all the kinks and all the problems and so forth to get to a ducted solution for ventilation, kind of right at the time when the Title 24 is requiring it. And not, if not requiring it, like in multifamily, well, then it's giving you a gigantic energy bonus by
Mm-hmm.
putting the ERV into your plan set in your Title 24. So that's the other motivator. So that's a bit about me.
Perfect intro. So here's how we're organized for today. We're going to cover ERVs. By the way, you've probably heard the term HRV and ERV. We're just going to keep it simple and call them ERVs because in most cases you're going to land on ERV as the right choice anyway. And that way it just saves us 6 letters, a terrible acronym with a slash in the middle, okay? So we'll talk about these systems. We'll talk about how the energy code requires us to ventilate buildings. We're focused on residential today, but many of these same concepts would apply in non-residential applications as well. We'll cover how they work to recover heat and save you energy. We'll cover the energy savings that are possible using these appliances and the resulting compliance credit in your energy models that come from that energy savings. And then we'll really shift gears and let Scott take the lead and talk to us about how he specifies and installs these right, which was a missing aspect of this course. If any of you came when I taught it in past years, now we've added Scott as a contracting expert who can bring that perspective to it. And Scott will jump in here and there, butt in whenever you want, buddy.
Okay.
Part of this course is based on this research study that a colleague of mine, Luke Morton, and I did for SoCal Gas and then Small Planet Supply on a modeling study of what ERVs can save in terms of energy. So we'll give you a link to that study. We'll refer to it in a little bit. But let's start by getting engaged. Menti is a little app I like to use to get you involved because we're not in one room. We can't read your faces. We can't see you raise your hand or squirm in your seat like you've got something you want to ask. So we're going to use these instead. So please point your cell phone at this QR code. It'll take you to our poll. And we're going to use this several times during the class just to pause and let you get your thoughts in and get them in anonymously. If you'd like to participate in chat as well, we firmly encourage that. In fact, let's stop whenever you have a question to deal with it rather than waiting for the end. Mike, in response to your question about ERVs, they are not mandatory. They're not mandatory anywhere. Mechanical ventilation's mandatory in single family and multifamily and non-res for that matter. ERVs newly in the 2025 code are prescriptive standard in certain climate zones in multifamily. And that to me is a huge change. And we'll cover that in that section. And it might be the writing on the wall for other occupancy types. I can't predict what's going to happen with the energy code, but it's certainly a strong signal that ERVs, balanced ventilation systems with heat recovery, became prescriptive standard in some multifamily settings.
Yeah. So also, I think, Mike, I said, Scott, it seems like you're saying ERV is mandatory in single family. No, it's mandatory in multifamily.
It's not mandatory, Scott. It's
Okay.
prescriptive standard.
Okay. And
we'll talk about the difference.
Okay. All right. So let me actually go back from multifamily real quick. So in single family, ERVs are not mandatory. What I was saying in single family is that you can get more credits for your Title 24 if you include the ERV. So, like for instance, there's credits for QII, quality installation of insulation. I believe it's 8%. So if you put QII in, then you would get this other 8%. And we're having problems because we have fenestration and all these other things are throwing off the calculation. And so the ERV is now upwards of 15% in most areas. And so then that would be the reason, the driver, why somebody would put it into the plan set. It's not mandatory. It just happens to be the biggest carrot that the Title 24 is offering us. And really, at the end of the day, the house is going to be tight whether I come over there and tighten it up or it's just built the way it's going to be built to this point in time and needs this type of ventilation anyway. So these things are sort of hand in hand, and then they're all, and the mandatory part is not there yet. So do you know when it does become mandatory in single family?
It doesn't.
It never does.
No.
Okay.
So look at these responses. Fresh air is the one that jumps out. A couple of people said that. Breathing, complicated, efficient, expensive. Interesting.
Let me see if I've got more. Let's see.
Yeah. Well, that gives us a good idea of where you're sitting today in terms of your understanding of ERVs.
Okay. Here's one real quick. I'm doing a new build and an HRV was spec'd in San Luis Obispo. What would the main reason to pick one or the other? So basically, an HRV means that the heat recovery is going to be a little bit greater than the ERV. The core is a little bit bigger. Basically, what I was doing is I was installing HRVs for the European brands over and over and over. And then we came to realize that really in the coastal environment, we really need ERVs. We don't need the heat recovery so much in this kind of a mild climate. And then the HRVs require you to plumb a condensate drain. And in our environment or our climate zone, it turns out to be a dry trap, if you will. Like, in other words, nothing's ever in it. And so plumbing that in tends to be somewhat of an issue. And so I think that we've kind of watched the industry just go straight over to our ERVs and simplify it that way. So that's why you pick one or the other. And I, you can install an HRV or ERV. I'm just letting you know those are the different, why
And
or
for
why not.
JA, we'll talk
Yeah.
through some of the
Okay.
differences among models and help you make an informed decision.
Yep.
But here's the value proposition from my perspective. They let you live better, sleep better, work better, and your HVAC run better. We'll talk about why that is. ERVs provide continuous ventilation for indoor spaces to dilute pollutants in our spaces and enhance indoor air quality. Right? The foam in your furniture, the chemicals you bring in, whatever you walk in on your feet are pollutants. And if we build tight, we've got to have a way of gradually flushing that out. And that's what mechanical ventilation does. And that's why it's required by Title 24. Now, ERVs ventilate much more effectively than what I call spot ventilation fans. And yet the code has always allowed us to just consider an exhaust fan running continuously in one bathroom to be a source of fresh air for our spaces and a way to flush those indoor pollutants. And I would argue that if you think of a sprawling ranch house that's 3,000 square feet, if that bathroom's on one corner of your lot, how well is that really flushing the pollutants on the other end? And similarly, if it's a 6,000 square foot, 2-story monster, it's not doing the job. So the beauty of ERVs is you can duct and distribute the exhaust and supply air throughout the building, better distributing it and better providing fresh air to the occupants. They also are different in that they keep neutral pressure in the home because balanced means supply and exhaust running concurrently, whereas exhaust fans running only, supply fans running only create negative or positive pressure, which is generally considered less efficient and less comfortable for people. The energy savings piece comes because ERVs are pulling in outdoor air, but they're tempering that incoming fresh air using the outgoing stale air stream. The streams never cross, never exchange pollutants, but they're allowed to exchange heat. And we've got a slide coming up showing you some example temperatures to give you that idea. But that's where the energy savings comes from. On a hot day like today, maybe some of you are at 90 degrees somewhere in Southern California. Instead of bringing that 90 degrees in that your air conditioner or heat pump has to cool, you might be bringing in that fresh air more like 82 degrees, less of a burden on your cooling system, and vice versa in winter. Now, the energy code compliance piece, this is what I do for a living. ERVs, I'm here to tell you, are the most powerful compliance credit in our book. It's the biggest button we have to press to get a project to comply. It's what we use when we have projects. We have one architect in Laguna Beach, for instance, and they have these beautiful sunsets on the west side of all these lots that they want tons of glass to face at. Like that house we worked on together, Scott, in Santa Barbara, similar, just panes of glass facing the
Mm-hmm.
sunset. Well, an ERV can give you enough credit to allow for those panes of glass facing the sunset. Or they can fix problems, like if someone forgot to do QII and they need to make up for it at the last step. So this is one of the best ways to get projects to comply. And that's a carrot that the energy code gives us to encourage us to include them in our designs rather than just the code minimum exhaust or supply ventilation. Health, to me, the number one reason to be covering this topic. They allow you to boost ventilation in your home. Scott's going to tell you why he recommends more CFM than the energy code requires. but the ability to boost it when you need it and then come back down to a normal level is a nice plus, especially when germs were going around during COVID. And by better distributing that fresh filtered supply air behind closed bedroom doors at night into these home offices that we all work in now, you perform better, you sleep better, you think better. So who can't get behind that? Let's do another Mentimeter question now. What's your experience level with these things? Scott, what do you guess? Most of them on the no to limited experience.
Yeah,
Okay, one person real familiar.
it's hard to say. I mean,
A couple. All right. That doesn't surprise me. To your point earlier, Scott, when you talked to HVAC subs about installing one of these, they didn't know how, right? They hadn't had the experience. These aren't mainstream yet.
they really aren't mainstream. It is interesting. If you go to a trade show, you'd think, oh gosh, the ERV industry is just like exploded. Everyone's making an ERV. And I think that what kind of is the missing link is the HVAC contractor doesn't know where that machine goes. I think
Mm,
sometimes the HVAC contractor thinks, okay, so this probably goes in line with my machine somehow, some way. And I think that that's kind of where we're at right now, maybe with the industry is in its infancy. And we need to break away from that. We don't put those two machines together. We separate those two machines. There's the heating and the AC, and then the ventilation, and those are separate. So once we
yeah,
can kind of get that out there and that information out there, it'll be much easier to consume and start, these practices of installing these things. And
yeah.
lastly, this has been going on in Europe for 20 years. They've got all this distribution. They set these systems aside. We're not talking about anything new today per se. It's just kind of new to
Mhm.
us.
Yeah, and obviously the energy savings from these is more significant in more extreme climate zones like Northern Europe, right? But we're going to talk about why it fits in California.
Yep.
So let me cover real quick why the codes require mechanical ventilation and how that's determined. To improve our indoor air quality, we should start with source control, right? We should not have a bottle of paint thinner open in the center of our living room. This is common sense, right? And so we need to bring as few pollutants into our indoor spaces as possible, but we can't completely eliminate them. And so the best approach we've found is the dilution approach, the mechanical ventilation approach. Um, the code requires spot exhaust ventilation in bathrooms and kitchens. Kitchens, that's your kitchen range vent hood. Uh, and it requires whole home, what we call IAQ fan ventilation. ASHRAE 62.1 standard covers the whole house, whole building ventilation requirements for non-residential buildings, and 62.2 covers residential. And that ASHRAE standard is the basis. Title 24 has rubber stamped that, has adopted 62.2 for residential building types. And why? Because increasing ventilation rates will reduce respiratory illness, associated sick leave, reduce sick building symptoms, and increase productivity. That was the CEC quote when they increased to a newer version of 62.2. And this Harvard study I'm referencing here, the charts show as CO2 concentration goes up, cognitive performance drops significantly on information usage, breadth of approach, strategy, those higher level thinking activities like your job. Okay. And this study found reduced ventilation brought down people's ability to think and perform higher order analysis 60%. And this is Harvard kids losing 60% of their ability to think. So if that doesn't get you interested in enhancing ventilation in your home office, I don't know what will. But now back under this the spot ventilation requirements. Title 24 introduced these new standards back in 2022. They're still the same, to have a minimum airflow over your kitchen range. By the way, the mechanical code requires that to be ducted to the outside, not just recirculating through a microwave hood. So don't let your contractor tell you otherwise. And a minimum CFM according to the dwelling unit floor area. That's not really what we're here to talk about today, but I wanted to make sure you were aware that there were other ventilation requirements besides just the IAQ fan, the whole house fan. Most homes ventilate with this fan, one or two of your bathroom exhaust fans running continuously, and that technically meets the code for single family. The code recognizes these three methods: exhaust, supply, and balanced, and in single family treats them equally, roughly. So let's look at each of these in a building science schematic. Exhaust ventilation shown on the left. We're pulling air out of the house, and we're assuming fresh air is coming in through infiltration through tiny holes in the envelope. Hopefully they're tiny. And that creates negative pressure in the house. Heat recovery ventilation, or ERVs, are a balanced ventilation system in a box that's pulling stale air out. That's the purple arrow to the left there, we're showing it up in an attic, and pulling fresh air in from somewhere else, swapping the heat in the two streams, and then allowing you to distribute that tempered fresh air where you want it inside the house, and pull stale air where you want to pull it from in the house. Pressure's balanced, and you're getting the benefit of the heat recovery. With an ERV, you're not just swapping heat of those two streams, you're also swapping moisture. And so that allows you to keep humidity in our dry climate in the house. In general, that's seen as one of the benefits of ERVs over HRVs that just swap heat. And the energy code, as I said, adopted 62.2 ASHRAE standard. That's how it calculates the minimum airflow rate based on the conditioned floor area and the number of bedrooms. It calculates a total required ventilation rate. There's actually another step where it calculates an infiltration rate, and then it subtracts the infiltration rate from this total calculation, and that gets you the fan airflow rate that's required. But look at this 2,700 square foot home chart. Notice based on different wind assumptions in each climate zone, a different amount of airflow is required, but it's a lot of airflow, isn't it? This is a typical four-bedroom tract home, and it's requiring 85 to almost 100 CFM to ventilate it. More than one bathroom exhaust fan could probably do. So that's what the energy code's doing. And you'll see in the box, usually right before the final page of your CF1R for single family, it'll show you that minimum airflow rate and how you plan to ventilate your building. In this case, exhaust ventilation without heat recovery. If you had specified an ERV, it would show it right here. It would show that it includes heat energy recovery and what the efficiency is, SRE, etc. Scott, tell us why you think Title 24 maybe doesn't require as much airflow as you think.
Okay, go back one slide, please. See in the lower left-hand corner, 02 airflow CFM 84?
Yeah.
That's the calculation that's in the plan set, right?
Yes.
Okay. So let's take that number, and I'm saying that number I believe is too low. So let's take this other scenario. And so I'm not starting an argument here because there's not. I'm in my room by myself here, and so
You're
I'm just
free
going
to
put
put
this
in
out.
more
I'm gonna put
airflow
this
if you
out there.
want.
Yeah. So the argument is it 7.5 CFM per occupant or is it 15 CFM per occupant? And we go back and forth on this with building science guys, where they're just like, I've always thought 7.5 was wrong, and I've always thought 15 was right, or vice versa, right? Well, I'm more on the 15, so I'm going to tell you why I think this. So I think it's 15 CFM per occupant. Let's think of the master bedroom. You've got a master bedroom, and it's a married couple, and they've got a family, and they've got dogs. Well, the two big dogs sleep in the bedroom with the parents, and a toddler sleeps in the parents' bed. And so we've got more people in there than just the two adults. The two adults, if it was 7.5, then maybe, and we're going to talk about tubes. Tubes are 3-inch tubes. If you look over here on my left-hand side, here's a tube, right? So this is the tube, and this is how we're going to deliver the air. When we deliver the air out of the tube, we're probably going to get something like 15 CFM. So often we'll put 2 tubes into the bedroom. And why 2 tubes? Because we have the 15 CFM if we're doing the 7.5 for those 2 people are in there. But then we really have to look at it like who's really in there. And so for sure we need 2 tubes. We need 30 CFM. And so that's kind of why I have that calculation, or I really believe that that's the answer. That's how many we need. And I also think for cognitive thinking, if I have 2 tubes coming into my office and I'm dumping 30 CFM on top of me, diluting, which in the room, which would be my office, would only be fresh air, filtered fresh air coming in, then I am going to be much more productive, like we were just looking at the study from Harvard. So that's kind of my argument on that. Now, the way that I build that, because we have to build this based on, how many rooms we have, how many tubes we have, well, where are the tubes coming from, etc. And so basically, I take a plan set and I try to figure out how many rooms do I have to supply and how many rooms do I have to exhaust. And so if we go back to the master bedroom and we think, okay, so we've decided we're going to put 2 tubes into the master bedroom to provide for the 2 adults, because we were talking about the tubes delivering 15 CFM each. We've already gotten past the argument past 7.5 CFM or 15. We're settling on the 15, but we got the toddler and the 2 dogs, so actually we need 4 tubes into the master bedroom. And so when I say 4 tubes into the master bedroom, you can kind of see in the background over here, there's a boot, and so those 2 tubes go into the boot, so you have these 2 boots that would be bringing in this air, right? So it's bringing in 4 tubes of air into the master bedroom, which theoretically would be 60 CFM, and the master bedroom door is closed, and then there's a bathroom, of course, in the master bedroom because it's en suite. So the bathroom is actually going to need 2 tubes, because by code, if we're not going to have the exhaust fan in the bathroom, then we're going to have continuous airflow of exhaust from the bathroom through the balanced ventilation system, that's the ERV, at 20 CFM minimum 24/7.
Yep.
So those 2 tubes in the bathroom are going to provide that for the code, but the bathroom contains a water closet also. So now you have to treat that the same way. So the water closet needs 2 tubes. And now when you look at this whole equation, you put it all together, it actually makes total sense. You've got the 4 in the master bedroom, you've got the 4 in the master bathrooms, and you're changing the air at an equal balanced rate. And you can actually measure the supply air and you can measure the exhaust air and have a true balance in them by doing some little adjustments with some of the dampers on the inside. So that's kind of the approach of how do you size this thing? How many people are in there? What does code say we have to do? Now, another caveat to that is when code says you have to have this many CFM, you don't go out and buy a machine that just provides that many CFM. We're going to get into that next. So that's my take on this portion.
See why I love having him here? And Chris Rosemont asked a good question. I think that's BASF, Chris Rosemont, right? Nice to see you. The compliance credit for ERVs blows the compliance credit for whole house fans out of the water. And whole house fans are ventilation cooling devices. They're not IAQ whole house fans. So we've unfortunately named whole house fans with a terrible name that
Yeah,
everyone misinterprets.
it's an
Um,
intermittent fan. It's a
yeah.
fan you run for 5 minutes.
No, you
No,
usually
the
turn it
whole
on when
house
it gets
fan.
cool outside and you open the
15.
windows and
Yeah,
you blow the air out your attic and you
yeah.
pull in that outside air instead of running your cooling system, your mechanical cooling system. So it requires cool nighttime air, which you probably have in spades in climate zone 5 and 6, but you may not have out in the Inland Empire. So it's very climate zone dependent. Um, and I find ERVs to be a much bigger compliance credit almost everywhere. Was there another question?
Yeah, Arthur,
Ducted heat
what
pumps.
do you think about using a ducted heat
Ah,
pumps air handler to move the 200
he
CFM?
anticipated one of our slides, didn't he, Scott?
Yeah, well, let's get to that. Let's just get to that, and
Get
then we'll
it.
come back, Arthur. Re ask a question after we get to that. Cover that.
All right.
Okay.
So I like to put this in. COVID seems like it's in a distant memory for many of us, but ventilation changed after COVID-19. I saw it especially in non-residential buildings where they set airflow rates higher, kind of like Scott's advocating for, than the code minimum. They started filtering return air more vehemently. They installed air cleaners and all kinds of other things. And part of it's because reports showed that going into a building without proper ventilation and just setting ventilation to the code requirement was the equivalent to vaccinating 50 to 60% of the occupants against the flu. Just a stunning impact of ventilation. There's no excuse if you're a building owner and you own an existing non-res building, let's say, you're not required to ventilate it. Well, you should because it's going to make those occupants healthier. It's going to make them better able to pay your rent. But I love this story. Stephanie Taylor is a doctor by trade, but she became a building scientist. And she has this group 40 to 60 RH that advocates for keeping relative humidity in that 40 to 60% range, that it's optimum for human health. And she likes to say that we building designers have a bigger impact on health than even clinicians. And the story she tells is she's working in a hospital and the architects designed this attractive wood paneling and it started peeling off the walls because the ventilation system was drying out the space so severely. They added humidity to try to keep the walls from peeling off and unexpectedly found that it brought down infection rates in their patients by accident. And that's what started her on this journey to advocating for optimal relative humidity. A quick note on this question of ERV versus HRV. Again, ERVs allow for swapping moisture and heat in that core, not just heat. HRVs just swap heat. So they're tempering the incoming air with the humidity of the exhaust air so that you've you've hopefully paid to have your humidity in that 40 to 60% range. You don't want to squander that by blowing it out. Um, Title 24, though, really doesn't care about humidity. It's not a regulated metric in a building. So it's not going to make a difference for your energy code compliance. What matters there is the recovery effectiveness and the efficiency of the fans. But your occupants might care. Um, and as Scott said, there's benefits on condensate drains and such. But Allison Bales, who's one of my favorite building scientists, he runs Energy Vanguard, which is an MEP firm in Atlanta, recently put out this book. And he had this quote: choice between an ERV and an HRV should land on ERV most of the time. It's only in mild climates where it doesn't get too cold, humid, or dry where HRVs make sense. And that might be California that he's describing, right? So maybe we get a bit of a pass on this, but I don't see ERVs costing much more, and so I've settled on ERVs for sure.
Yeah, I can kind of also say that I'm watching the American manufacturers, and they are definitely embracing the ERV. And I think that it's sort of more likely to get an HRV either from a European company or a Canadian company than it is to get one from an American company like Panasonic or Brown, etc.
Okay. I'm trying to understand Gabriel's question. Putting 40 CFM or the 60 that you recommended couldn't result in a high ACH. Of course, we're
I think she
also
means
ventilating the
could.
rest of the
Yeah.
house.
Yeah. So do I
Yeah,
favor, living rooms? Definitely. I favor, um, splitting all this stuff up is generally what we are doing is we're really trying to spread things out. And this is the only scenario where I'm sort of bringing more to it because in many of the homes that I'm working on, the master suite is considerably larger than the typical,
true.
um, you know, larger than my living room, type of thing. And so that's kind of where I'm coming from is that it turns out that the occupants are spending quite a bit of time in the master suite. And that's why I kind of treat that as the living room, if you will, instead of treating the living room, because I find a lot of those homes, the living room is just like a showpiece, and not many people down there are in there.
Yeah.
So that's kind of my take on that, Gabrielle.
Okay, that
And
that answers my question. Yeah, I know that sometimes, if you start adding it up, then the ACH starts getting above the 0.55. And I think that when I've seen drying out is when people leave it on when they go on vacation. But
Yeah.
okay, thanks for that.
Yeah.
So a quick cutaway of what a typical install might look like. You've got the box somewhere. You need to install two ducts, an exhaust and a fresh air intake to the outside. And then you need two ducts distributing those flows throughout the house. Generally, stale air is pulled out of kitchens and bathrooms, and fresh air is put in bedrooms and living spaces. But that's really up to you. And you may have specific considerations that encourage you to deviate from that. But here's how the airstreams swap heat and or moisture if it's an ERV in that center core. Okay. And I
We're going to
think
look
I've
at that core shortly.
yeah, pull one out in a minute. But here's the numbers on it. On a winter day, you might have 40-degree outside air. If you're just running exhaust ventilation, you're pulling in 40-degree outside air all over your envelope. So we can use the 70-degree stale air in the home, temper that 40-degree air, and maybe it comes in more like 60. And that's much less of a burden on your heater. In summer, on the other hand, you might have 100-degree outside air. Using the stale 75 indoor air, you're able to bring that down to 86 before you have to cool it. Does that make sense? And that's where the energy savings coming from. Now you're having to run two fans in an ERV situation, right? One exhaust, one supply, whereas an exhaust or a supply ventilation strategy just have one fan. So you're trading extra ventilation energy for saving heating and cooling energy. Here's a couple that I have running. This one on the left is installed. It was installed as a retrofit in this existing home. So it's suspended from the roof rafters in the attic above a bedroom. And I installed those ducts myself and wore out my knees pretty considerably crawling around that attic. But it was effective, and this supply vent here is one of them connected to that unit. It's been running since COVID, so 6 years. All I do is change filters. The one on the right is the one I installed for the ADU I built above my garage. And I became such a convert with the first one we installed, that when we built the ADU, I wanted to provide those tenants the same fresh air benefit. And so I installed that one down in the garage where I can monitor it and change the filters. But my tenants probably have no idea they have fresh filtered air. In fact, they open the windows all the time, and it kind of irritates me.
It's okay, Nick.
It's okay. This is a safe place to vent.
Yeah.
Um, Here's the data on the usage of that ADU. It uses about 60 watts continuously to provide 60 CFM to that one bedroom, 576 square foot space. That meets Title 24 and exceeds it a little bit. But notice that the green bars kick up to 70 watts periodically when the humidity stat in the bathroom senses that someone's taken a shower or something, and so it speeds up to eliminate that source of pollutant. Here's the temperatures. I put a hobo logger on all 4 air streams, and here's what it showed me. This is a period from June to December. The blue is the outdoor fresh air temperature, and you can see that varying here in Long Beach from about 46 degrees on the coldest November day, and we almost broke 100 in August and September of 2022. The red bars are the temperature of the supply air coming into the unit. So you can see visually that the range of supply air temperatures, the amplitude is dampened. It's cut like in half, right? By the heat recovery function. But overall, it's slightly elevated above the average of the blue bars because of the heat of the fan. And that's something for you to consider. And that's part of, I think, why ERVs aren't that popular in Palm Springs, where it's extremely hot, because that fan energy adds to your cooling load, right? And so these tend to perform better in my modeling in heating dominated climate zones, 1 through 5, 16, 10 and 12. But you'll also find benefit, especially from efficient ERVs, all along the coast as well. So I thought that illustrated it nicely. I also spied on my tenants' CO2 level. I put an air monitor in their space. And here's what it showed. It showed even with that ERV running, periodically they spiked up to above 1,000 CFM of CO2, sorry, parts per million of CO2. 1,400 one day. They must have had a bunch of people over. So it really shows the need for the ability to boost mode your ventilation system and provide extra ventilation when a lot of people come over. Now, here is a typical week in our closed bedroom door, our master bedroom, after I put the ERV in there. I used to run my central HVAC fan on a program to just move air in through the master bedroom overnight. It made my wife happier. We slept better. But that cost me a ton of money to run that big fan on a program like that. So once I ran the duct across to the master bedroom, we never spiked above 800 parts per million of CO2. So it really shows the benefit of that added ventilation. And then this picture is one of those air quality monitors. The left picture is when we checked into an Airbnb in Palm Springs, and it was a 73 out of 100, a really bad score, but it was CO2 that was pegged. The CO2 level in this bedroom was so bad because it was built before ventilation was required, and I found that fascinating. Whereas I was able to find this moment in time where I scored a perfect 100 in my office. Scott, you want to talk about some of the units? This was one of the questions we got early, right? How do we choose a good unit?
Yeah. Yeah, so here are three different units right here. Renew Air is a an American built brand in the Midwest, and when we look at it, we can see the kind of diamond in the center. That's the core, and you can see that there's filters on both sides. It's easy to see the one on the left. The one on the right is that orange strip. It's kind of a media filter, and so you have airstreams that are coming in over that core. And I've got a machine right here. I'm going to go through this machine. I'm going to open it up and show it to you after we talk about this. So that's generally what the ERV looks like. And it's hard to tell on the one on the left, but there's actually two ports on the right side that look just like the two ports on the left side. So you've got two going in and two going out. So the one in the middle, that's a premium machine. That's about twice the size. It's twice the money, almost not twice the money, but it's a premium unit. The filters that are in the middle they're a larger filter. There's a particulate and a pollen, and so that machine has a larger core, has better recovery, has larger fans, so it needs a larger box. The larger box is more insulated, so it's quiet. So it's like, how do you choose? Well, you choose based on the CFM that you need. That's how you choose. Do you want which premium unit do you want? Do you want the one on the far right where it's a 150 CFM ERV that's kind of the standard? It's comparable to pretty much every brand that's out there. Or do you want to lean over to something that's a little bit more premium, a little bit more insulated, better recovery? So it's really kind of in there. But let's focus on the ones on the right, the far right.
Okay.
Yeah. So that's the Aldi's 150 CFM. So when I say, how do you select one? The selection is based on the CFM that you need. So in the case of the 150 CFM here on the one on the right for $1,600 roughly is what the machine is, which the fresh air machine is. That right there is going to be run on about 50 or 60%. We're not going to run it on 100% because we just burn out our electric motors, right? And we don't want to do that. So every ERV that you select, every time you look at how many CFM it is, take that number and cut it nearly in half, if not in half. You're going to run it on half or nearly
The
on
fans
half.
are much more efficient at half speed, aren't they?
They are much more efficient, and it's
Yeah.
really not only the efficiency, not only the burnout of the motor, but then now you have capacity for boost, which is what we were talking about.
Good point.
So as
Yeah.
soon as you like, hey, I need to boost this thing, and it's 150, I'm running it on 150. Well, we've got no boost. But if we're running it on 85 and it's 150, we can boost that and then get some 60 minutes of boost, if you will, and get more ventilation in the home. And a lot of people are like, well, where do I put the boost switches? Well, they go in the bathroom quite often. People, they are in the restroom. They're going to take a shower. They hit the boost. They know it's going to ventilate and, move moisture and so forth. But some people don't use those boost switches, and maybe you don't want to put boost switches in every single bathroom. Maybe you just want to put it in one location. There's a party. There's people coming. You walk over. You hit the boost switch. You think it'd be a good for the boost switch to be on? The one operator of the home might be the one person that pushes that button because no one else ever thinks to do so. So that's the one thing I kind of want to like. The boost is one thing, but how do we implement the boost? Okay, so let's go to the next page.
And a couple of questions.
Yeah. Oh, okay.
In a smaller house, when an unducted ERV work, absolutely. You anticipated our next slide.
Mhm.
What does it do to the system if you open windows? Nothing. It keeps running. So it's sort of a waste when you open windows. So when I talk to clients who live on the coast and love to live with open windows, I usually tell them, well, an ERV may not be right for you unless you live large parts of your time with the windows closed.
Yeah, so I find, that's kind of always the argument of, no, we don't need your ventilation services. We open our windows. Like, that's fine. You can say that. But when it's 40 degrees, you don't open your windows. There are plenty of times when you don't open your windows. There's times where it's really loud outside or for whatever reason.
The landscapers.
Yeah, or there's certain rooms that you actually don't open the windows in that you said, so it's that kind of really, I think, is I let that one go. Does it really work when the windows are open? No. But does it exhaust the bathrooms 24/7 at the same time? Yeah. Is the window in the bathroom open? Maybe, maybe not. But the bedroom one is. So does that count? So at the end of the
Mm-hmm.
day, keep the ERV running, whether you open and live with doors open and wide and so forth or not. I will talk about the static pressure, and we'll get to that here, Mike. But I think it's coming up in another slide. I'm going to jump back to this, and I'm going to get back to static pressure for sure, because that's part of the equation. So on the left-hand side here, we have the Zehnder Q unit. That is designed in Switzerland, made in Germany, shipped to New York. Then at the time when I was purchasing them, my distributor was in Washington State. From Washington State to Southern California. So we're talking about a tremendous amount of freight for the European system. That's what makes Zehnder so expensive, is that it really, by the time you land it or you land the Brink system, they're very, very expensive. But they are the Rolls Royces. This is the Rolls Royce of ERVs and HRVs, in my opinion.
Yeah.
It's a 100-year-old company, Zehnder is. And the machines themselves are state of the art. And the reason why I've installed more Zenders than probably anyone in Southern California, I won't say probably, I have installed more of them than anybody in Southern California, is because when you buy the Zehnder system, you get the whole entire kit. You get all the tube, you get the diffusers, you get everything. You get everything in the whole kit, everything you need. And so the American ERV makers, they haven't gotten that far. They haven't figured that out. They don't realize the distribution has to be set alone by itself and not tied into the FAU or air handler, if you will. So my take on the Zehnder is that's kind of what kicked off the whole thing for me anyway into getting into this business. The only problem I had with the Zehnder systems is not that it cost like $25,000 installed into into a home, which is like a big number. Is that the manifolds are exactly the same, and we kept switching them and confusing them. So I'll get into that a little bit more, but Zehnder kind of was the thing that kicked off our pursuit into ventilation strategy. So if we go from Zehnder, we're looking at a machine on the left that's over $5,000. And now we're looking at a machine in the middle, the Panasonic, and here we are, it's let's say its list is $2,400, $2,300. And then the company that's selling it might be one of the online companies like HVAC Quick or HVAC Direct or who knows. And so they are selling these units at that $1,375 is $1,400. So now we're back in the realm of what every man can afford, these fresh air machines. And so that was kind of the big miss, is that we couldn't, the performance contractors and the passive house contractors were all putting these Zenders in and these high performance ERVs and HRVs. And then the industry, all of a sudden, because of code change, started to produce tremendous amount of ERVs, sans the ducting solution. So that's kind of what I wanted to get into. And so if we bounce over to the right side, we get into the Brown, a 150 CFM. So you could see that these are all kind of, you get the 120, you get the 160, you 150, whatever it is, and then take that number in half, and that's kind of the size that you should be buying. So let's go to the next page. Okay, is this a good time to open up the machine right behind me and look at the pieces and parts? I can't remember. Is this the slide that we would do?
Yeah, let's do that.
The last one? Okay.
Could you spotlight Scott for us, Danica?
Yeah.
I'm going to stop sharing.
Okay. So here is an ERV. I'm going to lift up the door here, and as you can see, this machine has its core right here. This core actually you could pull out and you could service it, which is sort of not done very often. If you were going to do it, then you were going to, blow it all out with a blower and vacuum it all out, once you pulled it out and so forth. But just to show you, there are filters that come with the machine, and you can upgrade these filters. They're on both sides, right? And then in the machine, you have the fans. There's the fan right there. There's the fan motor on one side, fan motor on the other side. And so basically we're crossing streams, just like this. Right here, you can see This is where air is coming in and air going out, or air coming in here. Here's the damper. I can feel the damper right here, and air going out. I'm going to show you how it works on the top part. So we've covered the fans, the core, and then there's controls. We close the door. We can actually tune the machine to what we want in CFM because, like I said, we're not going to run this on full. And then when we close the machine, and then down here you can see this is where I would put my thermostat wires or my 4 wires. My 4 wires would then go to a controller, and the controller would be somewhere. The controller would be the boost switch, if you would. You know, that's kind of what the controller does, is it gives you the boost, or it shows you that the machine is turned off, that there's some sort of a fault, you know, with electricity or something. So then, I'm gonna lay this machine right here, and right here, it's telling me which does what. So this one is the exhaust air to the outside. So this right here, I would run a duct to the outside of the house. It might go to the sidewall, and could be like a gooseneck vent, could be like a dryer vent, something like that. It could be a grill vent, and that would be exhausting air to the outside, and then I'd be bringing air in from the outside. So fresh air from outside is here. So this and this get ducted to the outside. One is sending air out, one is bringing air in. And so then I've got these other locations. So this is exhaust air. Okay, so this is exhaust air to the outside. I mix those up. This is fresh air from outside. This is exhaust air from inside. And this is fresh air from inside. To inside. Fresh air to inside. So, to simplify these two things, we'll put the manifolds on them, okay? So I'm showing you what a manifold looks like. It's got numbers, it's color-coded, it's graphic-coded, it's got the 6-inch supply, right, which is going to fit over the ERV. Some ERVs are 5. This happens to be 5, so we use a reducer along with this. And so we look at this and we say fresh air to inside. So fresh air to inside means fresh air is coming, needs to go into the manifold, and it's this one right here, right? So once this thing is plugged into it, now this could be anywhere you want it to be. This could be rigid duct to here. This could be flex duct to here. These could be up in you'll see in a video where we put them. They could be right next to the machine. But the idea is that one of these is a supply and one of these is an exhaust. And so you have manifolds for exhaust and you have manifolds for supply, right? So then again, go back to this. Exhaust air to the outside, fresh air from outside, exhaust air from inside. It's right there. So there we go. That's how we do this. So we're having a cross stream, right, to these ports through the core that's inside. And so what's super important when you're putting these manifolds on and we're ducting this is that you read this about 10 times. Because as you could see, I just read through it and had to like reaffirm which was which. So this is the key. This is the most important part. This is the area where we kept mixing up the manifolds from the European brands, because the manifolds from the European brands are silver. They're both silver. And we put silver, and maybe there is an arrow on both of them, but installers would mix that up and get that confused and not know, I'm putting fresh air to the bathroom when I meant to put fresh air to the bedroom. Now I'm putting exhaust air in the bedroom, vice versa, right? So that's how we came up with these manifolds and the coloring and so forth. And that's one of the companies that I have created out of experience in a test kitchen, which led to a lot of problems and I'm going to say under my watch and supervision, I'm going to say we mix up maybe a dozen of these
Did
manifolds
you?
along the way. Yeah. And so once you do that and you have to take them apart and go back to the job site and it's embarrassing and so forth, you come around to, okay, we've got to come up with a solution. So this slide shows you what a kit looks like. So we have a company, and this is not a pitch here. I'm just telling you this is how we solved this problem. Is that basically what we needed to do is replicate what the Europeans were doing. We needed to send out a kit, and you can see we sell ERVs, but I would say most of the kits that we sell are people that already have their ERV, and a lot of them are somewhere else in the country. Most of our sales actually are out of state in these, and so that means that they're putting our kits or our manifolds along with whatever ERV, and that's what I really encourage is now we have a ducting solution. Now it's okay to start specifying ERVs and start installing ERVs. So yeah, you can see all the pieces and the parts. There's everything you need to put these things together. There's 4-port, 6-port, 10-port, 8-port. And so then, and it's reasonable, $1,690 for 4-port with all the tubing that you need. It's under $2,000 for your whole ducting solution for an ERV. So that's kind of what we needed, and that was kind of missing in the marketplace, and that's how we kind of
Yeah, I
landed on
love
it.
that approach, Scott. And when you do the bottom-up CFM design in a minute, you'll see why the tube approach makes so much sense. Because I can tell you, when I ducted mine, I went from like a 6-inch HVAC duct to a a a boot that split it in two 4 inches, and then I transitioned the 4 to a 3. Like, it was a nightmare. And your manifolds and pipes just seem to make everything simpler especially for a DIYer or an HVAC installer for whom, this isn't their main work.
Yeah, and also what I can say is that if you look at the manifolds, it's home runs. We're going from the manifold all the way to the room of choice, whereas what you're doing is you're TYing or splitting air,
Hmm.
right? And so I can pressurize that box, and then I can run my tube however long it goes, and then I can go measure it on the other end. And that's what I think is super important about this whole equation is being able to measure the air at the final
And
location.
you've got dampers to adjust, don't you?
Yeah, there are dampers,
Okay.
within these guys right here. They're really kind of simple. They adjust,
Okay.
just like that, and then like this type of thing, same thing. It's just
Okay.
like that. So you put your flow hood, here, and you measure it, and you're like, okay, that thing is blowing 25 CFM. We only want 20. So then we can back it down a bit, and then that'll create more volume down the road
Awesome.
at another location.
Right on.
Should we talk about
Thanks,
static pressure
Scott.
for a minute? Should we talk about static pressure, or is that
Yeah,
coming
how
up?
do you factor that into your design?
Okay, yeah. So when we're talking about static pressure, and I'm like rule of thumb on the tubes, right? We have measured these tubes so many times. We've commissioned so many units that we kind of have a general rule of thumb. Like, okay, if that thing is well over 35 feet, don't expect more than 10 CFM. So that's kind of what my getting to the static pressure runs. So if I'm running 35 feet or less, something like that, i'm pretty I'm pretty confident I'm going to get 15 CFM in there. But when I go up to 50, forget it. So that's that. And these numbers that I'm throwing out might be adjusted 10 feet one way or the other. But what am I pointing out is that yes, in a 3-inch tube, there is static pressure. And that is so often why my prescription is 2 tubes to a room, 2 tubes to a run. Don't put one run into a bathroom and say, I'm going to get 20 CFM out of that tube. That's what my goal is, because you might not get that because you just don't have that many CFMs pumping into that pressurized box and traveling that distance. By the time static pressure gets to it, it's cut it in half. So therefore, we add that second tube. So now maybe we're over ventilating a bit, but we're certainly not under ventilating. So that's kind of my strategy. Why always 2 instead of 1?
Okay.
Static pressure.
Perfect. So I often get this question, what's the limit? What should we be designing to? And here's just a few research findings that I've come across. The Earth, as of a few years ago, was at 424 parts per million. They measure that out in Hawaii, where they think the air is well mixed. The Harvard study used 950 parts per million for typical indoor levels and 1400 as an extreme to avoid. But CBRE, a major owner of commercial real estate, used 800 in a presentation I sat in as their target. And for another data point, Title 24 uses outdoor concentration plus 600 as the trigger for demand control ventilation to kick in, which would be, maybe 1,050. So it's up to you. There's no real standard making body who's determined the right amount of CO2. But when you get up above 1,000 and certainly 1,400, according to that Harvard study, it's going to affect how you think and how healthy you are. And I'll give you an example. In this very room during COVID, my high school daughter had two friends over for a COVID classroom. It was the cutest thing, although the times were so bleak, it was hard to enjoy at the time. But I had the air quality monitor in here, and I noticed that their CO2 levels spiked like this on a school day. By about 10 a.m., they were above 1,400, and I knew enough to know that's probably not the best for those kids. And that's what prompted me to put in this ERV with 30 CFM into this space. And after that, their CO2 never exceeded 1,000. Great case study, I think. Let me quickly cover the energy savings possible with these, because that's why many of you will be interested. In our modeling study, a typical ERV can save 11 to 15% versus exhaust-only ventilation in those Northern California coastal climate zones, 1 through 5. That takes you down into 3C-REN territory, right? 4 and 5. We also showed savings in 10 through 14 and 16. 16 is the Sierras, 10 through 14 is Inland Empire and Central Valley. And 6 through 9, the coastal Southern California, Santa Barbara, down to San Diego, Irvine, LA, Palm Springs, less well suited for these typical recovery ventilators. And I kind of show you the math there. There's extra ventilation energy that kind of cancels out the heating or cooling energy savings to some extent. Whereas a best-in-class ERV, like we just showed you, the ones that have low watts per CFM, that is, they can move a lot of air with little energy use, and those that have high recovery effectiveness that swap at a really high efficient rate. That's what we're referring to as a best-in-class ERV. Now, these use less wattage to run, and they save more on heating and cooling, and the math looks better. So when we modeled typical ERVs in this study, and we've given you a link to it here, it's now a few years old, but the building science doesn't change. We found HVAC percent savings in the blue box accordingly here. Some of them were losers, right? The mild climate zones, we weren't saving energy. We were improving health. We were giving fresh filtered air. It was still worth doing, but we weren't saving on HVAC. But going to a best-in-class ERV, and now the savings were boosted to almost 20% in some climate zones, and now we're saving just about everywhere in the state. So that's the reason to go for low watts per CFM, high recovery effectiveness. It has a big difference. Now, one of the questions in the chat was, why aren't we using sensors to better control these things? And some innovative companies are. We're not going to plug any. We're just trying to give you real names so you can do your own research. But some have integrated heat pumps so that for low load dwelling units and multifamily ADUs. This one box can do heating, cooling, and ventilation. Others are able to do ventilation cooling like a whole house fan that Chris Rosemont asked about earlier by bypassing the core when the outdoor air is cool enough to be conducive to the indoor space. And we found savings of about 50 kilowatt hours in cooling savings possible using that type of feature. Boost mode we talked about, humidistat operation we talked about. Others use CO2 sensors to ramp up and down the delivery of fresh air according to demand. That's a concept that is in the non-residential Title 24 code for certain types of buildings as a requirement. So I encourage you to look through some of those models. What I thought we'd do now is show a quick video of Scott at one of his job sites so you can really see what it looks like to install one of these. Now just give me a thumbs up if you're getting audio through okay.
Transform the way you bring your next project to life at Ferguson Home. Discover an unmatched selection of kitchen, bath, and lighting with the latest styles from today's.
So here we are in Pacific Palisades, Hartzell Street, rebuild. If you can believe this, I was in this house before it burned down, and now here we are back working at this house once again. Hi. So what we're going to show you is how we duct an ERV. The ERV is sitting up in the attic right now, and along with it are two manifolds. There's a fresh air manifold and there's a stale air manifold. And so we go from the ERV to the outside with an exhaust and a supply, and that's two of the top ports. Air comes in from the outside, goes into the machine, goes over to the manifolds. Then the manifolds have 10 ports, 3-inch tubes, and those 10 ports are servicing all the rooms that need the fresh air on the fresh air manifold, and 10 ports and 10 tubes, 3-inch, going to all the stale rooms where we want to exhaust air, like the bathrooms, the laundry room, the kitchen, maybe even a closet or the gym. So this is how we're going to set this up today. Is we've got the manifolds, we're running the tubes, and the tubes are going to each room. Each room is usually getting about 2 tubes. And so we're going to show you what that looks like. Okay, so right there is a diffuser. It's round tube. We also have them in rectangular as well, but in this case, it really matches up with the recessed lighting. And so we've got a 3-inch tube, as you can see, and it makes its way all the way to the manifold. And there's another one right there. So this room is getting 2 tubes. And then we go over here into the bathroom, and we have exhaust in the bathroom. Here's one. We haven't run the tube to it yet, but we did set it, and it's lined up with the recessed light. And again, we've got another one right here. Tube still needs to be run to it, but we're almost done running tubes. You'll see them throughout the whole house already. And this is a client that I've installed ERVs for in the past. And he's always valued the fresh filtered air. On the downstairs, this area is really pretty wide open. He lives kind of wide open, he and his wife, and he does have 2 children. And but upstairs, they definitely wanted to have ERV and whole house ventilation in the bedrooms, in the bathrooms. And so that's what we're doing today. We are installing an Aldi's Inspire Air top port 265 CFM ERV up here in the attic. So we'll go up there in a second, but right now we can see Saul's trying to get the sidewall vent ready to install. We're using a roof vent gooseneck.
Sounds like a real construction site.
And over here we've got our roof jack that we're going to use. And the unit is right up there. So we're going to go up there now. Okay, so we're up in the attic right now. And there's our machine right there. It's actually next to the heat pump. And our system is going to duct straight out of the roof here for exhaust. And do you see way down there is Judy? You can see her. Oops. And she's getting ready to connect ductwork to a sidewall exhaust vent. Supply. So we're bringing air in from the sidewall at the back of the house there, bringing it in to the machine. From the machine, we're going straight out of the roof to a T-top with mesh. From the machine, we're going over to the fresh air manifold. And from the machine, we're going over to the stale air manifold. And you can see the stale air manifold only has 2 tubes left to install, which we saw those in one of those bathrooms. And we can see that the fresh air manifold still has 4 tubes to install. And then that's done. And it's all nicely strapped because we like everything to look really good. And there's another couple of holes that we had to drill. But other than that, this was almost a no drill. The hole hog is the main tool we use. And 3.5 inch hole saw, because we're pulling 3-inch tube through the holes. So thank you for joining me today and watching this video on how you install an ERV and how the ventilation kits can help you do your job installing an ERV. We sell ERVs.
All right.
Okay.
Any questions in the chat before we move on?
Okay, is the attic going to be insulated? No, the attic is not going to be insulated. Well, yes, the attic plane is going to be insulated. Is it an unvented attic? No, it's not. It's a vented attic. I would recommend an unvented, and I would have put the insulation on the roof deck if it were me, but that's not how the builder did it. So this is Pacific Palisades. This is a coastal community in Los Angeles, and that attic will get hot to some degree. That ductwork will be affected to some degree, but I'm not really terribly concerned about it. I'm really concerned about changing the air in the house more so than how the potentially hot attic might affect the machine. The machine is totally insulated, but the ductwork does not, as you point out. Let's see. I joined late. What was the best strategy for installing an ERV in an existing home? If you have an attic in your existing home and you have, gables and all that, and, you can crawl around in there. If you can crawl around in there, you can put a machine in there. You can duct it to the outside by going out the gable walls, sidewall, gable wall. You can then go in, so you've got all your rooms. This is the way it is for my house. You have all your rooms, and they're all drywalled and everything, and you probably have can lights in there, or maybe you don't, maybe you do. And you basically go and try to line up where you're going to have your locations in the existing home, and then you figure out where those locations are going to be, and you go ahead and you drill a hole, and you drop down the diffuser boot, which is something that looks like this thing. I'm going to take the tube off of it. I'm going to take the grill off of it. That's 5 inches right there. So that's going to be on the protruding through the plaster or the drywall of your existing home, your living room or your bedroom or whatever it is. And you're going to hang this up in the attic. You're going to use probably what are called hanger bars, which kind of like can lights. You install these bars, on the sides, and they open up, and then you can then hook them onto the ceiling joists in the attic plane and so forth. So yes, you can definitely put these into existing homes. I'd say half of the ones that we install are in existing homes. If you have a flat roof and you have a crawl space, then you do have an opportunity to go from underneath. So yes, that's the answer to that question.
And I agree, it would be even better to not have it in an unconditioned attic. But that space is so gold in California homes that a lot of them end up there.
Yeah,
But
mine
if
is.
you could put it in the laundry room, even better. That's more accessible to change the filter. I
Hmm.
have to I have to deconstruct my daughter's old closet to get up and change the filter. It's not the best setup, but and if I were doing it for a client, just a regular family that isn't overly energy efficient conscious, I wouldn't have put it up there. I would have figured out some other way to make it more accessible, and it's going to
Hmm.
operate more efficiently if it's not exposed to those extreme temperatures.
Yeah, and so there's a couple more in here that I'm going to answer. The answer about the unducted ERV in a small house.
Well, I've got one to show them.
We are going to get to that slide. Yes, we
Yeah.
have those. We have unducted solutions, no question about it. I would call them spot ERVs. It's kind of the way we refer to them in the marketplace. And then yeah, the manifolds are definitely based on how many rooms you have, and we've got the red dot map coming, right?
Yes.
Okay, red and blue dot. So that's going to answer that question here soon. And then it seems like a lot of ducts if a large ranch house style home. Yeah, it is a lot of ducts. It's 10 for supply and 10 for exhaust. And like I said, you would split those up. So it'd be like, we say 10, but it's 5 rooms because it's 2 tubes to each room. So you have 5 rooms. If the ranch house has 5 rooms that you need to supply and 5 rooms you need to exhaust, the exhaust would be the bathrooms, the laundry room, the kitchen. It could be a gym. It could be an AV room. It could be, a whole bunch of different places and things that people will use an exhaust line for. Some people have a closet or a cabinet inside the home that has a lot of chemicals, the household cleaning materials, and so they'll put an exhaust, just one tube, into that room per se, and exhaust air out of that. So there's many ways that you can utilize your exhaust and supply. If you find, oh, I need this many supply, and it turns out I only needed 8 tubes of exhaust, well, then put 2 more tubes somewhere else where you think they might be beneficial, even in hallways,
Scott,
etc.
I'm gonna stop
Yeah,
you there in the interest of time. 3C Ren always likes me to cover the code aspect of this, so
go
that's
for it.
what this section's going to do.
Yeah,
And then we'll get back to questions.
yeah.
So when are they required? And this came up right in the beginning. First, ERVs are never mandatory in residential buildings, but they are now prescriptive standard in half the state for multifamily. These climate zones that are colored in the chart here, it's prescriptive standard to have ERVs in new multifamily buildings. So it's more than half of the square miles of California, and some of the most densely built climate zones, like the Central Valley in Sacramento, but some of the least populated climate zones as well, 14, 16, benefit the most from ERVs. So I saw Pam Bold on with us today from High Sierra Ren. These are going to have even more benefit in your areas, Pam. Um, so multifamily buildings today, and this is a big change for 25, have two choices for IAQ ventilation, balanced or supply. What did I not mention? Exhaust. Exhaust is forbidden now in multifamily. So this was a huge change for 2025. And blower door testing of all units is mandatory to confirm that these things have been built tight so that the ventilation systems aren't just swapping air from unit to unit, they're bringing in actual fresh air. So 1, 2, 4, 11 through 14, and 16 multifamily have an ERV prescriptive standard, and they need to meet certain minimum efficiency, 67% recovery effectiveness and zero 0.6 watts per CFM. So if you use the performance method of compliance and use an ERV about that efficient, you'll stay pace with the code in those climate zones. If you use a best-in-class ERV, you'll open up a nice compliance margin. And if you install one in a climate zone that doesn't have ERV's prescriptive standard, you'll open up a nice compliance margin as well. So the converse of that, though, is if you try to build a multifamily building In 1, 2, 4, 11 through 14, and 16 without ERVs, you're going to take a stiff compliance penalty that you have to make up for elsewhere. So here's the compliance impact in the 25 software on LSC efficiency in all 16 climate zones for a typical ERV, 20% on average. This moves the needle way more than a whole house fan, more than high performance walls, high performance attics, even batteries. And best in class ERVs are going to fare even better. Okay, so that was single family. Multifamily is different because now in the prescriptive standard is balanced in the 25 code for all climate zones, which means that there's no fan energy penalty to go to an ERV, and the energy savings relative to standard are larger. Okay, so like I said before, in those 8 climate zones, you'll keep pace if you install them. In the other 8, you'll open up a compliance credit. So will the 28 code push ERVs even further? Well, single family still allows exhaust ventilation for IAQ. There's no prescriptive standards for ERVs in single family. But I think the beginning of this requirement in multifamily certainly portends something to come for single family, but not in 2028 because AB 130 that passed Sacramento prohibits updates to the residential code for 6 years. So at the soonest, it would be 2031. Rebecca, LSC efficiency is long-term system cost efficiency. That's the key performance metric that Energy Code compliance uses. But it's not the only one. Peak cooling, source, LSC total also have to be met. It's a complicated world that we live in if we do energy modeling. But here's how you would specify an ERV in the CBEC software. On the left is an exhaust ventilation default. On the right, you've specified an ERV or an HRV, in this case, 55 CFM. You get to tell it if the air supply filters and recovery cores are accessible by checking that box. By the way, if you don't check that box, you lose all compliance credit. So accessibility is required, and you can read the code for that definition, but it generally means within 10 feet of a floor surface. You're allowed to put it up in the attic, but if you do, it has to have a FID, a fault indication detection system. And that's what that second checkbox is. If you don't put it up in an attic, FID is worth basically an extra 10% on your compliance credit. It's not mandatory, not required, but it does result in better compliance credit. And here's sort of some details on what's happening under the hood when you add an ERV to your energy model. Your proposed design will have the airflow watts per CFM that you entered, and it's going to assume the outdoor air comes in at the temperature calculated using the recovery efficiency that you entered, right? It knows your indoor temp, your outdoor temp, and it's going to do that calculation. The standard design we're compared to has the airflow we entered up to 125% of code minimum. So if you exceed 125% of the code requirement, you're going to get no added benefit. So don't do that. Stay within code minimum up to 1.25 of that. Watts per CFM will be modeled at default. So if you have a system better than 0.7 watts per CFM, your compliance benefits. And it's going to assume no heat recovery. That assumes we're not in one of those 8 multifamily climate zones where heat recovery is prescriptive standard. In that case, it will have that heat recovery. I'll give you a case study, and then I'll pause for questions before handing it back to Scott. This was 6 duplex projects I did in Climate Zone 8. the compliance models that we designed that we thought would be the optimal path to compliance had what was then called the VCHP credit. That's like a ductless mini split. We got a special credit in the 22 code for that. Now you just model it like any other heat pump and you'll get a credit. We had a condensing upgraded gas tankless water heater, but the builder missed those features. They built it without. They used a central ducted heat pump that didn't qualify for the VCHP credit and a standard gas tankless. So I wrote him this email. I've done the what ifs. If you remember, we told you how to build this and you ignored us and we were tight on compliance. So here's two options. Add rigid foam to your walls. Of course, do they want to do that after the building's built? No. And above the roof deck, that would have been incredibly invasive and expensive, but it would have got them into compliance or at an HRV. And I tried to explain to him what it might mean. It's one of the few things you can do afterwards. And that's what they did. So we went from the left compliance screen, 1.2 points away from compliance, to the right compliance screen, complying by 0.3. And Title 24 saved the day, but we can't always save the day. Any questions? What software? CBAC is what I was showing, but Energy Pro also can show compliance with the energy code. What type of person does this type of modeling work? Yeah, we're called energy consultants, and I saw there's a couple of Quebec mentees studying to become energy consultants on this session right now, which is fantastic to see. Quebec's the Association of Energy Consultants in California. We have a certification called CEA that shows we've learned the code and we know how to model for compliance. So that's my quick answer there. Let's keep moving though. We're down to 20 minutes, Scott. What do you want to cover in terms of rough cost?
Yeah. So we kind of looked at a couple of pages earlier. We were looking at premium units. We were looking mid-range units. A mid-range unit is $2,400 or less for an ERV. That's what the fresh air machine costs. That's the box, right? So when you do that, you put that machine in, you then have a ducting kit. We talked about the ducting kits and how those kind of run. We're going to get into that a little bit more in a minute and kind of layout. And the kits on a large unit, one that's going to give us the CFM that we need, is going to be maybe 3,100, between like 1,700 and 3,100 between those, 4-port, 6-port, 8 or 10. So let's just say $3,000 on the ducting, right? Now the ducting kit has all the 3-inch tubes and so forth, but it doesn't include ducting to the outside. So you might have some flex duct, you might have some, we were in the video, you could see we had a T-top, we had a gooseneck. The goosenecks are $50, the T-tops are $50, the box of flex is probably $50, something like that. So when you go into that install number of $4,000, you might want to say, okay, I have additional ductwork on top of that I would put on top of the 4,000, or if the 4,000 is enough, and this is more of a production number, 4,000, multiples of these houses, if you would be 4,000. So 11,500 is like the base place where you have let me say this one more time. So roughly for 11,500, you have an installed whole house balanced ventilation solution, right? So you're taking the exhaust fans out of the equation if you want to. You can have the exhaust fans in the bathroom if you want to keep them in there, and some people do. I have teenagers. I do have exhaust fans in my bathrooms because of that reason, because they take these everything showers that last for an hour. And so in that case, if you were to take the exhaust fans out and you were using balanced ventilation only, you're doing exhaust through the bathrooms, as we talked about, 20 CFM 24/7, then you would remove the exhaust fans in the equation of whatever your house build was.
Yeah,
as far
that
as
might save you $1,000.
Mm-hmm.
Yeah,
it could save a couple thousand, because you have the electrician, the electrical,
right,
the ducting, the unit, all that stuff.
Right.
So then If you get into a larger home, you're probably looking at double that. So we're talking about maybe 23 or $24,000 for two full complete machines. And if you were to take that up to premium, you might add 2,000 on each, so it'd be like maybe another 4,000.
Okay.
So it's like basically you could have two full complete running machines for the same price that you can do one European machine for.
Okay.
So kind of to give you a breakdown, multifamily, there are 1 hour firewall issues that go along with that. And so multifamily is going to put us all on the same chase as the heating and the cooling is going to be. And so that's going to be like an economy of install. So that's kind of about how much these things cost.
There we go. We're keeping it real here. A lot of presenters would have left cost out of the discussion, but it's important.
It really is.
Here's the map when I put the one in my house that I had an MEP guy map out, and you can see my system only covered the living areas on the left side of the house, didn't cover the 2 beds and 2 baths on the right. I eventually added a duct to get to the bathroom on the right. So the key questions to think about as you consider getting into this business or doing your own house: where's the unit go? What's the route the ducts are going to take? What's the CFM each room needs? Where the supply and exhaust register is going to be located? And that penetration of the building envelope is a really important detail. How are you going to get to the fresh air and exhaust the stale air? And maybe some occupant controls, because everyone loves the ability to interact with that system. It makes it seem more valuable. So I really like, for that reason, those systems that come with some sort of control panel. Scott, why don't you take us through the bottom-up approach you use with your tubes to size your systems?
So these are the tools I use for my job and my calculations right here. So I got these 2 Sharpies. And if you look at the map and you look at the layout of this floor plan that's right here in front of us, what you can see is that I took the blue Sharpie and I went to the office and I put 2 tubes in there. That's what each one of these dots mean. It means that there is a tube in that room. So in the office, in the upper left-hand corner, I put 2 in there, right? We went cognitive thinking when we're doing our work.
Mm-hmm.
And then in the bathroom, I put 2 tubes for exhaust. And then the ADU, you're looking at a house that is an ADU and a house in one. This is one of my close friends. This is her home in Hawaii, and
okay.
she's tearing down the old home and putting in a new home. And she's always been like, I want people to visit, but I want a place to put them. And so that's why there's an ADU like within the house. So in case you're like, ADU, yeah. So what I did with the ADU is I sort of undersized the exhaust, if you will, because I only put it in the bathroom, but I put supply in the rooms, the office and the ADU, because it's basically it's going to be open door. My friend is going to be using the office. The ADU will be used when somebody shows up, and so forth. So then you go over to the kitchen, which is on the right hand side, and you see 2 red dots there. So I put 2 in the bathroom and the ADU, 2 in the kitchen and the ADU. Now I'm going to the bathroom for the guest suite, and I'm going to put 2 in there. And I'm going to go to the master bath, and I'm going to put 2 in there. And so then now we go to the master bedroom. We've got the 2 blue. So there's the balance there. Go back to the guest suite. We've got the 2 blue there, right? So this is a system where we're using just 8 supply and 8 exhaust. But if we were to do 10, let's say we wanted to do 10 exhaust and supply, then in the dining room or the living room, we would definitely be putting 2 more supply.
Mm-hmm.
And in the exhaust, we could bump that up in one of the bathrooms if we wanted to. Like, for instance, when you have a bathroom that is sort of like the guest bathroom or the powder room, and people are going to be using it when you're doing having a party and so forth, that's a good room. Believe it or not, the smallest room in the house is to over ventilate it or over exhaust it. So like I said, you could add, this is 8 to this house, but you could add 10. You could add 2 more to the living room and dining room, and then you could use those 2 exhausts in all kinds of other areas if you wanted to. So let's go back to that slide real quick.
Yeah, you went
Because
to.
I want to show, see the garage, see the washer, dryer, water heater, sink, all that stuff. So when we're talking about putting in the laundry room, that's what we're talking about. This is a carport. This is a garage, rather. It's a garage with the laundry room, in it, if you will. So technically, I guess the machine would be in the garage. But when we say let's put the machine in the laundry room, we're going above the washer or the dryer or the sink. We're taking that cabinet. We're putting the machine in that cabinet. You open up that cabinet. You get to open up the door of the ERV and you put your filters in. That's what we're talking about when we say let's put it in the laundry room.
That'd be
Now,
great.
yeah, the manifolds can be up in the attic plane and they can go do their own thing. But to have the machine where you can see it and where you can service it is kind of what we were talking about. And that's what's going to happen here in this house. Is that garage that you're looking at is actually got this gigantic, almost 5 feet space above the ceiling, and that's actually where the ERV is going to be. There's going to be a pull down stairway, and the surfboards and all that kind of stuff will be up in that room, if you will. So we call that a mechanical room. And that's the other thing I would like to touch on is, like, if you could put the ERV in the mechanical room, if there is a mechanical room, then that's where the ERV should go. If there's not, then we're going to have to make one, if you will, and that's where we would put it in this particular house. So we can move on. Yeah.
Love it. So you just saw Scott's bottom-up approach to calculating CFM. You've got to make sure that meets the Title 24 minimum, right? It probably does. And then choose a model of ERV that has twice the maximum airflow of the one you want to run at 24/7. That allows them to run more efficiently. As you can see from this chart here from a major manufacturer, the watts per CFM, or it's actually showing CFMs per watts, it's best in those mid-range airflows. It's much less efficient when you get up to 163 CFM in this example. So in Scott's example, he got 120 CFM with his bottom-up approach. Title 24 would have asked for 97. So you specify a model with 200 to 250 CFM, somewhere in there, or 2 units with 120 each. Notice that at 115 CFM, this unit works less efficiently, higher watts per CFM, and lower recovery effectiveness than it does in that mid-range. And that's why Scott uses that as a best practice. Now, Chris Rosemond asked about ducting an ERV into the main ductwork. I explained in text why we don't advocate for that. You can read that at your leisure. Other units go through the wall. The middle unit here is called Lunos. It's a German technology with a ceramic core. And what's funny about these is one will be running in exhaust and its pair unit will be running in supply mode. So in that way, they're balanced. And then they switch direction. And then they switch direction another minute later. So every minute, roughly, they're switching direction, and that ceramic core has thermal mass to it. And that's how they, in effect, temper the incoming fresh air. Pretty funky design. They're only up to like 20 CFM, so you'd need pairs in rooms all over your house. But another interesting approach that doesn't require ducting. The Zender unit on the left, I think they call the 70 unit, is also a through-the-wall unit with a little bit more airflow. They don't require installation in pairs, but they allow for, I think, 30, 40 CFM. Is that right, Scott?
Yeah.
That unit? Okay. And I wanted to spotlight myself. That sounds so arrogant, but I'm going to do it anyway.
Do it.
And show you this unit here that I have on the bench. This requires ducts to the outside for the supply and exhaust. Am I full screen? Or do I need to stop sharing?
You need spotlight.
Let me stop sharing for a second. Okay.
Yeah,
There we
that's
go.
better.
So picture this in the ceiling of a small ADU or a multifamily studio or one bedroom. This is a 60 CFM max rate unit, so it's great for that 30, 40 CFM everyday range. And all it needs is a duct for the exhaust and the supply to outside. And this manufacturer even makes a pant leg boot that allows you to put both of them through one penetration and then does its best to separate those two air streams. But what's going on under this hood is the exhaust is coming in right here. So if this were installed in a bathroom, for instance, it's going to be continually pulling in stale air right here, and then the supply air gets distributed through the other grills. It's got an integrated MERV 13 filter. Notice how thick that is. I should have mentioned supply and balance ventilation systems is mandatory to have MERV 13 filtering the supply leg of a balanced ventilation system in California. So you need to make sure you pick a system that has that capability. So I really like this adaptation because it eliminates the cost of ducting the supply and exhaust air around a small dwelling unit in a way that might allow for ERVs to be installed in multifamily buildings and small units more cost effectively. Now, I just got a few more slides. Scott, you want to quickly describe what we got here? I don't think we have time for the video.
Okay. So basically what we're doing, you can see this video. It's 45 seconds. You can see it online on YouTube on Scott Kelly Construction. But basically what I did, and you'll see, is this bathroom right here has 4 ducts to it, and it is connected to a Panasonic fan up in the attic. And Clara goes through this and explains it to you. You can see it's funny actually. And so basically she's just taken one of our red manifolds, put a Panasonic fan on it, exhaust, and then ducting the bathroom, if you will. So you can take these manifolds and do all kinds of oddball things with them. It doesn't have to be just part of the kit. So that's one of the creativity aspects.
Very attractive too.
Yeah.
Yeah.
Those vents, they're front and center because it's my house and I kind of wanted to illustrate it. But I could have the ones on the top all the way at the top, and I could have the ones at the bottom all the way at the bottom, and so that the water closet, just like complete evacuation, right? It's great.
Yeah. I also want to point out this is the ADU I built above my garage. I built it out of SIPS panels, and by using a ductless mini split for space conditioning and an ERV for IAQ and local ventilation to do that bathroom exhaust function, I was able to vault the ceilings because no longer do you need an attic to store an air handler. You don't need a flat surface to install your bathroom exhaust fan. So it's really a nice plus of using an ERV because as long as you've got 20 CFM in that bathroom running continuously, you don't need an additional bathroom exhaust fan. HVI directory is a good place for you to look up various models. It'll give you their CFM capability, their watts, their recovery effectiveness. So let me do a final check-in here with our last few minutes. What are your takeaways? What are your lingering questions? And then we'll let Danica sum up. Yeah, and I don't think those health benefits are well known.
Yeah, and so one of the questions was understanding the bottom up design is instead of taking the number of the CFMs that the plan set says you're supposed to have, I really just do it more as a rule of thumb. And so my rule of thumb is I generally want to run 2 tubes to every room for supply or for exhaust. And so when we're all done with the bottom up approach, we're going to probably find out once we measure everything and we put X amount of CFM into the manifolds and deliver it all that and so forth. We're probably going to find out that that strategy, because there are 2 tubes, not just 1 tube to each room, probably going to find out that we're over ventilating a little bit, not a whole lot, but at the end of the day, when we say ventilate, what ventilate means, we didn't really talk about this too much, but we showed you these various equations that get to this number, the ASHRAE 62.2 and so forth. But basically, just as a rule of thumb, what that means is that we're changing the air in the home every 3 hours. It's a little less than 3 hours, but roughly, let's just say every 3 hours we want to change the air. So that's kind of the bottom up approach as I'm looking at, is like, okay, I got to change all this air. I've got this many occupants. I've got this many rooms. I've got this many red dots to exhaust rooms and this many blue dots to supply rooms. And at the end of the day, I'm like, oh, this house is so big, I actually need 2 systems to do this. Or this house is perfect for just one system of 10 ports or 8 ports and one ERV. So at the end of the day, that's kind of what I'm trying to get to, is what the cubic feet area of the home is that's supposed to be evacuated every 3 hours and supplied every 3 hours. I'm basically just using this rule of thumb of the 2 tubes are going to deliver me between 20 and 30 CFM to each room, or exhaust 20 to 30 CFM to each room. And then I'm going to use that number and I'm going to build that number, and then boom, I've got the CFM number of what kind of ERV unit I need to select based on its CFM capacity.
And there was a question earlier on commissioning, which, Scott will do with his fresh pitot tubes and stuff. But let's say you find you're getting 160 CFM and you really only thought you needed 120. You can just dial down the speed of that system and set it to run there. So there's that post-commissioning step too, right, Scott?
Yeah, and the commissioning thing is a tricky one. And if there's anybody that makes their living on commissioning, don't take this the wrong way, but what happened with the European brands is they would layer on commissioning services, and it could be $1,200, $1,600, and a lot of times these people are flying in from another part of the state to do the commissioning, and they're putting the flow hood on every single supply and every single exhaust and so forth. And that can be very arduous and expensive. And then you can get some of the commissioners that are like, oh, you blew it, you got this wrong, and this is too much and that's too little, and you need to rebalance the whole thing and get the client all worried and so forth. At the end of the day, I throw commissioning out the window. I'm just like, okay, I know how many CFM I'm going to put into this house because I've selected the unit, I've selected the manifold, and I know how many CFM roughly between 10 and 15 CFM, maybe up to 20 per tube, depending if they're super short runs, then maybe I might get that. But generally, I'm going to just have a general rule of thumb, like I said, and that's how I approach it. Once I've done that, basically, I don't go back and measure everything and try to balance everything. I just go with what the install is, and then I'm getting my air change. And am I getting the exact air change in bedroom 4 as I'm getting in 1? Maybe not. But am I getting the air change throughout the house as a whole? Yes, I am.
There's the real world perspective from Scott Kelly. That's why we love him. And I think you might have isolated situations where the resistance to airflow on the exhaust side is different enough from the supply side that you do want to do a little commissioning and balancing to get them back in balance, but not often. I mean,
Yeah.
the distances are going to be pretty darn similar on your supply and exhaust.
Yeah.
Yeah, but John's point's valid.
Yeah.
So closing takeaway, I hope you leave with ERVs allow you to be your most productive selves. We've given you some links here. Scott's got a wealth of videos on his various sites if you want to dig deeper into this, and by the way, into waterproofing and efficient building envelopes. I listed Energy Vanguard here, my favorite building science guy. Green Builder Media has helped me a lot. Energy Code Ace for all the code references. And Scott and I want to thank you. This was our first time teaching this new version of the class. Thank you all for showing up and your insightful questions. That was great.
Yeah, good time, guys. Thank you so much.
Yeah, thank you so much, Nick and Scott, for lending us your expertise this afternoon. And thank you, everyone, as well, for being here and spending your afternoon with us. I just launched a survey, and it would be great if y'all could fill that out. We take into account our survey responses into our, whenever we build a course or, um, and yeah, I highly recommend putting any courses that you'd like to see that 3C Run offer, what you would like to see 3C Run to offer. And yeah, sorry, it's late afternoon. Um, and so if you have any additional Title 24 Part 6 questions, or Part 11, feel free to reach out to our code coaches online, and you can find the web form on our website at 3c-ren.org/code. And if you have any questions with receiving your AIA or ICC units, those should be distributed automatically. But if you do have any questions, feel free to reach out to my email on that slide if you have any additional questions on that. And just to reiterate, we will have the slides and the recording of this session into your inbox in the next few days. And we do have a lot of upcoming courses, but I like to highlight our future courses with Nick Brown. So if
Ah,
you'd like to see him in person next month, he will be in Oxnard doing a heat pump water heater installation training at the Cedar Valley Plumbing Supply in Oxnard. And then another one is September 1st on a 2025 energy code, specifically on multifamily ventilation. So if you want a deeper dive on that, feel free to also attend that course. And with that, we are at time. So thank you so much, everyone, and hope to see you in a future webinar.
thanks, Danica. Scott,
Thank you,
great
Danica.
job.
Thanks, Nick. Good job.
Thanks for all the help putting that together. I love it.
Yeah, came off nicely.
Yeah.
Thank you.
All right. Take care,
Bye.
everyone.
Bye.
Bye.